Hey Superstar students, it's Dr. Conklin here to do a short video with you on literal equations. We are on page 32. 32. Today we're going to talk about, literal equations. So the word literal, if you think about it, you guys see literal almost sounds like literature. Literal means that we have letters in the equation. Now, we will usually have numbers, but usually it means we have more than one letter. And remember, equation means we have an equal sign. So we're going to try a few of these today. Let's start with number 1. It says solve for t. So these are sort of new directions for us. We haven't seen a lot of questions. Or we know we're usually asked to solve for t. The first question here, though, if we look at it, we want to get t by itself. So what are we going to do to get t by itself? Well, 2 and t are connected by multiplication. The opposite of multiplying is dividing. So here, t equals 6. So our answer here is a number. What's a little different is when we do b, is that our answer is not going to be a number. It's going to be sort of a combination of variables. So let's look at b together. Same directions. We want to solve for t. So we're going to ask ourselves, how do I get rid of that r? And that r, that r is connected because we have a multiplication operation. So the opposite of multiplying is dividing. So we're going to divide both sides by r. So t equals d over r. And it's really wacky, but that's actually our answer. And we just leave it like that. Okay, so let's try the next one. This is like I would like star this one. This is a really, really important one to know, especially for our upcoming test. So let's start first by just solving for x here. So if I look at this equation, here's my x, and I see that I have a variable y and a number. Now this you guys might recognize is slope-intercept form. You probably learned that last year. We're definitely going to do more with it later. But this question is saying, how do I get x by itself? Well, first thing we need to do is realize this is an equation, so I can sort of divide it up. And I want to get rid of this minus 1 first. How do I cancel a negative or minus 1? Well, I want to do the opposite, so I'm going to add 1 to both sides. When I do that, I'm left with y plus 1 equals 2x. And again, it's a little tricky, but let's stay with it. I'm going to circle my x. What operation is connected to 2 and x? That's multiplication. So the inverse or opposite of multiplying is division. So we're going to divide both sides by 2. And again, this looks a little bit weird because our answer is not going to be a number. Those cancel. I bring my equal sign down, and I'm left with y plus 1 over 2. So that's my final answer. It is wacky, huh? Let's try the same thing here. And this is actually our slope-intercept form with m and x. So this has all variables. We're not going to get scared by that, though. We're going to start by solving for x. So we're going to do almost the same thing we just did. I want to first start by subtracting this b. I want to cancel that b. So the opposite of addition we know is subtraction. So I'm going to subtract b from both sides. And again, this is where it gets weird. Y minus b is on the right side. Oh, that's too big. So y minus b is going to look like this. I bring down my equal sign, and I have mx. Okay? Now, same thing here. Oops, sorry, that's a little hard to see, guys. Here's my x right here. How are m and x connected? Well, the opposite, these guys are connected by multiplication. The opposite of multiplying, we know, is division. Remember the fancy word for the opposite operation is the inverse operation. So let's divide both sides by m, because that's what we want to get by itself. So bring my equal sign down. Here's x. So y minus b over m equals x. So that's our final answer because x is all by itself. Okay, let's see, what other ones did we want to do today? I do want to go for number 5 because this fraction bar can be tricky. So let's try 5 and then might wrap it up for the day. So we have this fraction bar here, which we need to sort of remember. There's almost like magical parentheses around here we can't see. We got to first get rid of that division by 2. So we know the opposite of dividing is multiplying. Oops, and I didn't even read the directions, guys. Here we're solving for y. There's only one, the only variable here is y, so we're not doing too much. So I'm going to multiply both sides by 2. So y minus 5 equals 3 times 2 is 6. And then how am I going to get y by itself? I'm going to add 5 to both sides.
Do something that my teacher asked me to.
Okay, I'll be right there, Charlie. 1 second. Can you go back and listen? I'll be right there.
Why? Because she isn't even talking about me.
Okay, 1 second, honey.
She doesn't even think I'm there.
Okay. So now if we look at this one, sorry guys, I had one of my helpers come. So here's y. So same thing, we're going to get rid of this m first. So let's multiply both sides by m. I'm going to cancel this, cancel this. So I'm left with y minus b equals x times m. Or you could just leave it like xm, and remember by commutative property, mx would also be exactly the same thing. And then again, we want to get y by itself. So I'm going to put my little division here. The opposite of a negative b, that's what we want to cancel out. So remember, the opposite of subtraction is addition. So I'm going to add b here and add b here. So y equals, you can write this a couple ways, but x times m plus b would be a perfect way to write it. Or you could do b plus x times m. Remember, that's commutative property as well. So that's our final answer. Let me know if you guys have questions. This is a tricky topic, so we're actually going to cover it more tomorrow as well. And I will post the homework for you. Have a great day. I'll draw you a quick cute flower because you guys are so awesome. Oh, it sort of looks like a starfish, but yay. Oh boy, I've definitely drawn better flowers. All right, have a great day, guys. Keep up the awesome work. Bye.